Hello, let's see lab 2, in which we shall try to make use of the same SSD1306 library, but this time a new library called FrameBuff will be using. And as like before, we are creating an I2C object and binding the bus to it, the SCL and SDA pins, and then after creating the display object and binding the I2C library to it, I2C bus to it. And we also create a dynamic buffer called images, and we open the binary file, try to read some data, and rest of the data we try to load it and display it on the system. Let's see how it works. If you go into detail, the main objective of this lab is I want to print a binary image onto the display. When I say binary image, it's basically ones and zeros only, because the displays here, the SSD1306 is a truly binary display. So a 1 shows you a lighting pixel, glowing pixel, a 0 shows you a dark pixel. When you invert the display, it becomes reverse. So this is our objective. Now in this case I am trying to print an Udemy object, Udemy picture. So it's your wish, you can pick whatever picture you want to. So I've already selected one image and downloaded it. This is the image I want to convert. So my image name is download. So now I want to convert this image which is there. You just open it with Paint, and you see the resolution being 239 by 92 pixels, and our display size is hardly 128 by 32, right? In most of the cases the display size may be much more also, or it can be much less also. So we have to now resize the image. So a very proper good tool, what I found out is ImageMagick. It's an open source tool which will give you the advantage of resizing an image into any format that you want. Let me download that. You go to the Windows section. You have it for iOS and other operating systems also. This is the one for Windows binary release. Download it from here. I've already downloaded one. So let me install mine. Okay, I'm done. And now how should I resize my image to the display size is the challenge using the tool. So for which we already have few commands. I'm trying to access the ImageMagick tool using the command magic convert. This is the input image. I want to resize it to 128 by 32, and this exclamation symbol tries to force the resizing option. Most of the cases what happens is ImageMagick tries to convert it to a suitable viewable image resolution, which I don't want it to happen. So it forces it to 128 by 32, and this is the output file. A PBM is the binary format of a file. So this is mandatory that you have to convert this the file into this output format. This is the file name. I've just put it 0.pbm. It can be anything else. So this is the command I'll be using. Let me go to my image. My image is here. Even you can use a MicroPython image also to reforce it and convert it to 128 by 32. So let me open my command prompt. So inside the command prompt, I am in the same location where my image is also present. So I've already installed my software. Let me copy this command and execute it in the command line. Yes. This is not recognized as an internal or external command. There is some problem. Let me close my command prompt and open it again. Let me go to the standard location where my image is present. Copy this. Unable to open image download.jpg, no such file or directory. We just need to see what happened. So the image file format is .png. I have mentioned it .jpg, so it's a mistake. So let me rename it to png. Yes, I have a 0.pbm created. This is the binary file. Let me open it with the editor. You'll see P4 being one some comment and 128 by 32 is the comment dimensions of the image, and rest all the things are we are not able to view them in the standard editor as because they are in binary format. Now let me take this 0.pbm and paste it in wherever my project is present. So let me go back to PyCharm and open my lab2. I have opened it, and here is the 0.pbm. I have put it. The other folder I have tried to exclude it. You can make the directory exclusion. You can cancel it and you can exclude also. Again, okay. Let me coming to the code. There the code is quite straightforward. You have binded the I2C to the display. Then you have taken a free buffer called images. Now I am trying to open this 0.pbm file, and f is the object which tries to hold the file that you have opened. So f.readLine is a method which tries to read the first line. The first line is the unwanted line that you have. You can read out that, and the second line is the dimensions. You can read out that also, and the remaining is the image. So I have captured all the image data onto this object called data. This is a variable, it's an array. I have captured into that. Now FrameBuff is one such library which helps you to access the buffer very fastly with priority on MicroPython. So I have given the access of data buffer to FrameBuff, and I've also mentioned the size of my display, and this is the mode of the reading. And Blit is one routine which is being used to update the images fastly. In our case, there is only one image which has been copied into FrameBuff. In the next lab what we are coming up, we'll have multiple images being looped, with which you will see an animation. So I have given access to FBuff. So FBuff has been passed as a routine, passed as an argument in the routine of Blit, which makes it to update the image fastly, and finally display.show shows me the image. So if I run the image, if I run my project, 0.pbm and my main.py will be copied onto it, and finally I'll see an image something like this.